Today we're going to talk about my 8031 computer system, which is connected to a 16500C Logic Analyzer. So this is an HP16500C Logic Analyzer, and it has a 25 megahertz state analyzer in it. The part number of the state analyzer, the module that's in there, is a HP16500A. So what I have here is I have this is pod 1 here is connected to the address bus, and pod 2 is connected to the data bus. So I'm going to have some resources at my website to tell you how this thing is connected along with the clock. So we're going to talk about this, trying to reverse engineer the software that's in this device using the 16500C Logic Analyzer. So this is the front of the Logic Analyzer. I haven't powered it up yet, and this was rescued from the junk pile, and I guess they're pretty obsolete now, but maybe the more modern Logic Analyzers are not obsolete, but this one, being it's only 25 megahertz, that's pretty slow. But anyway, we're going to take a look at the back of this thing next to show you how the cables are set up. So this is the back of the Logic Analyzer, and it has space for 1, 2, 3, 4, 5 cards. They're designated A, B, C, D, and E, and right now I only have an E card in, which is the HP16510A 25 megahertz state, 100 megahertz timing card. So I'm going to power up this Logic Analyzer right now, and hopefully it'll make it through its startup. So we'll watch that just to document how this Logic Analyzer starts up. So the object of this task is to reverse engineer to get some code out of this processor. If the code was unknown, what I'm going to do is compare it to the listing. I'm going to look at the address and data bus as a little program runs on this device, and we'll look at the assembly listing and try to reverse engineer it. So it is starting up now. There it goes, it started. So now I'm going to show you how to set this up to be able to look at this device. I have pod 1 and pod 2 connected. Pod 1 is connected to the address bus, and pod 2 is connected to the data bus. Now I also have a clock, it's called the J clock, that's attached to pod 1. So anyway, the first thing to do is to just select the system here. So I'm going to show you what it's all touchscreen controlled. So it's a state timing E card that I'm interested in. So I have pod 1 over here, and I want to do state. I don't want to do timing analysis. I want to do state analysis. And pod 2 isn't assigned right now, so I believe I have to assign that. So I push pod 2, and I want that into machine 1. Okay, so notice that there's some arrows here. If I do a reset on my card, some of the arrows will change, and those arrows tell you that there's activity because I have it connected right now. So I'm going to push the reset on my processor, and I'm going to type a command that'll do some things. So there is some activity there. As you can see, those arrows are changing. So again, this is the setup of my 8031 minimal system, and I have a computer here that I'm using Teraterm with. I'll show you over here. You can see the monitor. Try to zoom in on that a little bit, and I could type different commands. Like N brings up the menu. It talks to the 8031 through RS-232. So the one program I run, I type a J and it jumps to 800 in the user ROM. So I'm going to trigger off of that because that's where my program starts. So I'm going to do that to try to capture the code that's going into that processor. So this is a good way to reverse engineer a processor or troubleshoot one if there's something going wrong with it. Logic Analyzer is a great tool, probably the only tool you can use sometimes when you have a bad processor, or if you're trying to troubleshoot software that you can't seem to get to work properly. Okay, now back to the touch screen. So this is probably one of the early touchscreen devices that has been out there. A lot of the technology was probably started by HP for touchscreens. So it's not as good as what we have today, but it's not too bad. So anyway, we're going to set this up to look. I'm going to show you the setup just using the touchscreen. So I go to configuration. So the first thing I want to do is do format. So the things I need to do is I'm going to call this pod E1 is pod 1 and E2 is pod 2 because it's in the E card, and I'm just going to change this label to reflect the address bus. So I'm going to modify the label, and I'm just going to type an AB for address bus, AB, and oops, I want to clear everything first and type AB. So this is my address bus. And I'm going to add a label for my data bus, which is pod 2. So I'm going to do that here, and don't want to do anything here to B. So we're going to modify this label. We're going to turn it on, and then we're going to modify it. I'm going to keep that one off. It's a little hard to push these because I'm offset a little bit. Okay, so we're going to modify this label, and this is going to be called the data bus. I type DB, done. So what I want to do is turn on the 8 bits that I'm connected to here. So I'm going to hit, so the first 8 bits are just going to be points, which are don't cares, and then I want to make these 8 asterisks. So done. Okay, so one other thing I want to do, this is might not be exactly TTL, so I want to set a user threshold for these rather than using TTL. I'm going to set this to 4 volts, the threshold, because a lot of things are 3.2 volts now. I know this is a 5 volt system, the old 5 volt. So our clock, which is connected, is called J, and we want to do it on the up arrow, so that is set properly right now for what we need. So if I let this run, this would be like free running. There are some numbers here. So this is the polling routine that I have in my monitor program, which is at 0794. This is the address bus, and this would be the code in the data bus. So I actually want to trigger off of 800 where this program runs, this program that I have that's running. So we're going to do that next. So to set that up, I need to go to trace. So I'm going to do this, I only really want to look at it one time on any state. So that's set up properly the way that is. So I want to go here and set this one up to 800 because that's what I want to trigger off of. Oops, I don't want that one. Is it done with that one? I just want that one. Okay, so I type 080 done. Okay, so that's my 800 there. So when address 800 is hit, it's going to trigger. So I like to go back to the format page first, and then I'm going to hit run. Oops, I don't want symbols. I'm just going to hit done here. I want to hit run. Okay, so it's waiting to trigger. So if I type a J command, it'll execute the program at address 800. So I'm going to do that right now. So I'm going to hit J, and up you can see it. So that's our code here that we have. So you could see 800 here. And so what I want to do is scroll up here a little bit, as far as I can. And so I scrolled up there, and I'm going to take a photo of this so I can compare it against the code. I guess there is a way to download the data, but I'm not too sure how to do that right yet. So this is our address bus or data bus. So this is the code over here. So I'm going to take a photograph of that and compare it against the listing to see if that is see if, if it makes sense or not. So one other thing you could do is look at it, and rather than a listing form, is look at it like a timing diagram in a waveform form. So if I hit that, you could see the waveform, and I can push it down a little bit, and then we could turn some markers on, and we could go vary the markers. I believe hit that, and then yeah, you could go and scroll through. Now it only shows half the address bus, so it's only showing 0 to 7, but I want to get the whole address bus. So the way to do that is to yeah, I believe you click on here, and we're going to just delete all, continue, and we just want to get the address bus. So that would be A, B, and yeah, best fit, done. So this is our address bus. So now I believe we could scroll through this. Right, so right there where the red line is, you can see that's 800. So that's 800, and you could see this over here. That would be like 801 and 802 and 803. Let me zoom in here a little bit. So you can see it a little bit better. So you could see like where the 800 is, it would be right where the red line is. So that's like a 1, 0. You could see the 800, and that's 801, 802, 803, 804. So you could also look at the data that way also, which is a very interesting way of looking at it. So anyway, I'm going to go take some pictures and compare it against the listing, and we'll try to talk about that a little bit. So I wanted to show you a few other things here with the HP16500C Logic Analyzer. This is a view looking into the pod connectors. So what it is that pins 2 through 17 here represent the 16 bits. And there's also a clock signal here. This would be the J clock on pod 1, pod 2 would be called the K clock, and so forth. There's 5 of these connectors coming out of the HP16510A card that was in slot E. So this is the connections that we had going from our 8031 to these pod connectors. Only pod 1 and pod 2 connectors were used. So there's a little trick here. You always want to connect the ground before connecting the clock, otherwise it jams up the system. So it's important to connect the ground, then connect the clock in that sequence, and you may have to do a restart. It's best to have the system powered, then connect the ground, then connect the J clock. The J clock was connected to pin 19 of pod 1, which is this pin over here. So I took some photographs of the listing that I got on the Logic Analyzer, and I wrote down the hexadecimal numbers. This is the data bus over here, DB, and this is the address bus. So I was able to get 3 photos. So I went from like 0 to 15, and sometimes we get these doubles. So there's these doubles in there. I've seen that before. And I think that's just the way the microcontroller works. Sometimes it puts out 2 pulses to keep things aligned in timing. I'm not 100% sure why it does that. Stop. So this is the second page, and this is a loop that keeps repeating itself. So I wanted to just get a little more data here. And this is the third photo. The loop repeats itself. And this is a listing, the assembly language listing with the machine code over here that's supposed to be showing these numbers. So what I did is I made an Excel spreadsheet, and I put in what might be expected with the addresses and what I observed, and I did get a match here. So sometimes there's a prefetch where before it jumps, you see the data, and then sometimes things get doubled. So it seems to get doubled. It's very consistent where things are doubled. So I think that's just the way that processor works. So anyway, this was an interesting project, and hope you learned something here. And I'm doing this just to try to maintain these logic analyzers, just trying to put them to use to try to understand them better. So anyway, hope you like this, and I'll be working on this some more. Bye now.